Hello students, in this video we will be talking about the November 2017 paper 2 question 7. This is a question on normal distribution and it is worth 7 marks. Let's read the question. The heights of adult males in a country are normally distributed with a mean of 180 centimeters and a standard deviation of sigma centimeters. 17% of these men are shorter than 168 cm. 80% of them have heights between 192 minus h and 192 centimeters. We are asked to find the value of h. Now first, let us define our variable. So in this question, we are talking about heights of adult males. So let's go ahead and say that x is heights of adult males. Okay, so x follows a normal distribution. Its mean is 180 and the standard deviation is sigma. So here we need to write sigma squared. It is unknown, so we have to leave it as an unknown. So in the first part, we are told that 17% of the men are shorter than 168. Let's go ahead and write that in probability form. So the probability that x is smaller than 168 is 17%, which I will write as a decimal, 0.17. And the next part tells us that 80% of them have heights between 192 minus h and 192. Also going to write that in probability form, but we probably only use that later. So 192 between 192 minus h and 192, that makes up 80%, which is 0.8. Let's work on the first part. First, we need to make sure it is left tail. It is left tail. Next, we will standardize it. So z 168 minus the mean given is 180 divided by sigma equals to 0.17. Nothing else changes. Let's go ahead and evaluate this number. So probability of z smaller than negative 12 over sigma gives 0.17. Right? If you like, you can have a little imagination about how the graph works. So if you have standardized, this axis will be 0. And in order for the area to be so small, this part, it should be on this side. And this number is negative 12 over sigma. All right, so let's also go ahead and use the inverse function, inverse normal CDF. And let's use area 0.17 mu 0 sigma 1. That is the reason why we need to standardize it, because we will need to enter a value. All right, let me show you on the calculator itself, and the calculator will help us give this number. So you turn on your calculator. I hope it's not too blur. All right, and then you depress this to get to this page. All right, and then you press menu. Okay, and then you press probability, which is 5. And then we choose distribution, which is also 5. And then we choose the option 3, which is the normal, inverse normal. Okay, make sure you have the inverse normal. And we will go ahead, there's a glare, I'm so sorry. And we will go ahead and fill in this as I've written just now. So the area, we will want 0.17. And go ahead and say okay. So the calculator says it's negative 0.954165. So this number in here, negative 12 over sigma, is negative 0.954165. Now take a moment and reflect upon the graph. This is a negative number. Does it make sense? If this is 0 and this is on the left, this number is a negative number. seems to work. So now we're supposed to find sigma, and sigma will be given by 12, negative 12 divided by negative 0.954165. Sigma should always be a positive number. You can also use that to check if your answers are correct. I will put this in the calculator, but I wouldn't show you the calculator. You would get 12.5764. You can round it off, but please write the more accurate number because you will need it for later calculations. So 12.6. That's how you find sigma. Next, we're going to work on the second part of the information. We are given that 80% of the men have heights between 192 minus h and 192 centimeters. This is exactly the same thing I wrote down just now, using a new piece of paper because we are out of space. All right, so we are going to first standardize this probability. So we're going to do the same except that there is an upper bound and lower bound. So we're going to go ahead, 192 minus h, and then subtract the mean, which is 180 in this question. I'm going to keep sigma as it is because the decimal is very long to write. Now we have standardized, so change x to z, and do the same for 192. So 192 minus 180 over sigma. Do nothing to 80%, so it still equals to 80% or 0.8. All right, I'm going to go ahead and simplify this. 192 minus 180 will give us 12. So 12 minus h over sigma z, 12 over sigma. And those of you who are sharp will realize that the second part of this is a reflection of what we have earlier. This is negative 12 over sigma. This is 12 over sigma. What does that mean? If we were to draw a little sketch, we'll know that if this is 12 over sigma, this part will be 0.17. Okay, because the reflection, since this is standardized, this will be 0. So when this number is reflected, it will be the exact same area. Anyway, let's carry on. So we will also use the fact that if z is between two numbers, upper and lower bound, we can subtract the areas of their lower tails to get the answer. We haven't changed 80% at all. All right. Let me now try to illustrate this with maybe a diagram, might help you understand a little bit better. So this if this line is here, okay, this area, and if this number is the lower bound, let's say here, let's draw the same lines. All right. Doing this, the bigger area minus the smaller area, we will then get this middle part. Yeah. Okay, so let's write in math. So this first one, if this part is 0.17, this part would be 1 minus 0.17. It's from 0.17 is from here, which is from the previous part where we have negative 12 over sigma. This is sigma. Okay. We can't do anything about this part. It has h involved. I'm going to just write the same thing down. And I didn't do anything to 0.8. Okay, now we're going to have to do some manipulation. I'm going to move the probability to the right hand side, and I'm going to move 0.8 to the left hand side. So I have 1 minus 0.17 minus 0.8 is the probability that z is smaller than 12 minus h over sigma. Right? If we evaluate this, we will get 0.03 is this probability. Now let's swap sides so that is less confusing. Now this is a left tail and it's already standardized. We're going to go ahead and use the inverse normal, and we're going to go ahead and tell them we want the area to be 0.03, and because it's standardized, mu and sigma will be 0 and 1 respectively. Okay, let me now show you on the calculator. The number we get will be the number for this limit. Okay, I'm going to get this number from the calculator. So we turn on your calculator. And get to this page. Right, menu, 5, 5, this time 3. Put in the area 0.03, mu is 0, sigma is 1, okay. Negative 1.88079. Negative 1.88079. All right. So now I'm going to go ahead and look at my sigma from earlier. I'm not going to use this rounded off. I'm going to use the whole string of it. All right. So 12 minus h over 12.5764. This will be equals to negative 1.88079. Okay, I'm going to multiply by the denominator. 12 minus h is negative 1.88079 times 12.5764. I'm going to use the calculator to work that out. You should get negative 23.6536. And again, I'm going to move the h to the right hand side and the 23.65, negative 23.65 to the left hand side. And the negative becomes a positive. So h is 35.6536, approximately 35.7. That's all for this question. Please let me know if you have other questions regarding this.